So a standard application of Green's theorem is to use it to replace some kind of nasty line integral with a much easier double integral. So just imagine what would take place if you tried to set this one up the usual way. You'd look at the curve. So you'd say, okay, well, we'll parameterize it with 3 cosine t, 3 sine t. And then you'd be looking at setting this up from 0 to 2 pi, and you'd have 3 times 3 sine t minus e to the sine of 3 cosine t. And about at this point, you sort of lose the will to live, and you just want it to end, right? But it just gets worse. And that's where you give up and cry. Okay, so what we do instead is we use Green's theorem. So Green's theorem tells us that the integral over c of p dx plus q dy is equal to the double integral over the bounded region of partial q dx minus partial p dy with respect to d area. So let's go back to our function here. And so this is our p and this is our q. So then we have, this is over the disk now. So this is going to be from 0 to 2 pi, and I'm going to set it up in polar, so from 0 to 3. And then we have, so the partial of q with respect to x is 7, and the partial of p with respect to y is 3. And then, so that's r dr d theta. And so we have 4 times pi r cubed, or squared, pi r squared, and we get 36 pi without even breaking a sweat. Bam! That godforsaken, miserable nightmare of a mess just put out of its misery.